Right. I told you I'd do some videos, so here we go. This is now if you follow me. So get your textbook. You haven't got your textbook? Go get it. Press pause. Right, good. Turn to page 1, and it's all about kinematics and describing motion. Now look at the bottom left of the screen, and you'll see quite simply speed is distance over time. It's called average speed because your speed might have changed in that time. Okay, you can write that using symbols: V for speed, X for distance. That's what it tells you in your nice formula booklet. Okay, turn over the page, and it talks about the difference between average speed and instantaneous speed. Instantaneous speed is at a particular time. So please now do the question about calculating the average speed, question 1 SAQ. Press pause. Now, carrying on from that, talking about units, you need to know the units. Okay, distance can be measured in lots of different ways, so speed can as well. Top right of page 2, you can see that quite clearly, different ways of viewing units of speed. Have a go at question 2 and 3. Press pause. Okay, so next, determining speed. You can find speed by doing loads of different things. You can do it in a lab using data loggers. You can find out speed with speed cameras. Turn to page 3. Speed camera just looks at 2 different pictures, and they show the distance on the road. So you know the distance, you know how long it was between the 2 pictures, and as a result you have a distance and a time. You can work out speed. You can use light gates, which measure speed either at 1 gate or a speed, but using 2 gates. Again, just doing a calculation of distance over time. Turn to page 4. You can do it with ticker tape, an old way, little dots, one printed every 50th of a second, every 0.02 seconds, and that puts a little dot. When the dots get further away, it's clearly going faster, and you can see that is accelerating. Okay, there's other things like motion sensors that give out a ultrasound rate wave, and it uses the Doppler effect to see whether it's going further away or coming towards you. So again, there's different methods you can use, but if you want to have a go at the SAQ questions on that, they are question 4 and 5 on page 4. Press pause. Okay, moving on. You can talk about distance and displacement, scalars and vectors. The first question, which is always on the... I haven't turned my laptop on. You see, I forget my textbook, so I use my laptop, and then I don't plug it in, and then it turns itself off. Yeah, right. Page 5, distance and displacement, scalars and vectors. The start of almost every question in the paper, the question 1 will usually be about units, scalars or vectors, or something quite simple, straightforward, basics. So just know this: distance in a certain direction is called displacement. Speed in a certain direction is called velocity. Okay, the one with a direction is a vector. The one without a direction is a scalar. So remember that. Scalars have size, which is correctly called magnitude. Vectors have direction as well as magnitude. So there's examples if you want to read through that on page 5, talking about those things. But the definition of speed is the rate of change in distance, and the definition of velocity is the rate of change in displacement. If you ever forget those in the exam, look at the equation sheet, and they come from that. Rate just means divided by time. Okay, so you can see all that. So the symbols they use in the book are on page 5. Have a look. Distance, displacement, time, and speed and velocity are all there, and with their very standard units. Okay, so have a go at question 7 on page 5. Pause. Right, okay, page 6, speed and velocity calculations. Again, velocity is rate of change in displacement. Okay, there's a worked example on page 6 and page 6. There's 2 worked examples, so you can have a little look about that. It's all just about rate of change of displacement. Okay, if you can use units, you can do whatever you want with the units. Just make sure you're consistent. If you have it in kilometres, you'll get a speed in kilometres per hour if time is in hour. So just be careful. So if you want to check on, you can do that. Have a go at question 8 and 9 on page 7. Press pause. Good. Right, displacement against time graphs. These are quite simple. Okay, look at the unit on the side. If it says S for displacement, then it's clearly one of these graphs, and a straight line means it's going at a constant speed. If it's flat, it's not moving. So the gradient quite simply tells you how fast it's going. Steeper means faster. Look at the picture, top right of page 7. Okay, it's all quite clear. In fact, I'm going to point at it if this works. Yeah, kind of. Okay, constant speed, faster speed, higher gradient. No gradient, flat, no speed, not moving. Okay, that one means it's going at constant speed. and then it's going at a constant speed again, but this one is going in a negative way. That means it's going backwards, back to the start. The displacement is negative because it's a vector. Okay, and this one here is getting flatter. The gradient is getting less, so therefore it's slowing down. Okay, so that is what those graphs on that page actually show. Okay, that's page 7. Alright, so if you roll on, you can have a go at a question on the top of page 8. Question 10 will go on about that. Press pause. Hello, did you do question 11 as well? Good, well done. Right, so velocity from a displacement against time graph, just find the gradient. There's an example showing you how to do it on figure 1.13, middle of the right hand side of page 8. So you can have a look at that if you want, and it goes through that. Press pause if you want. Okay, if you don't want, have a go at some questions yourself. Draw some graphs, work some values out. Okay, so question 12 and 13 are like that. So you can do the graphs, just do a sketch with the right numbers in the right place. You have a go at those. Press pause. Good, okay. Remember all the answers are in the back to these, by the way. But then there's a summary question, summary, shall I say summary again? Summary statements. Learn them, okay? You need to know what they are. I don't like the definition though. You will get a mark for that in the exam, but it's better to call velocity rate of change in displacement. Okay, and then the basic facts are there for you to know. And you can now have a go at the questions on page 10. They're actual exam questions. See how you do. Press pause. Ooh, actually, don't press pause, I've nearly finished. So that is chapter 1, Kinematics. See you on the next one. Bye. Oh, actually, hang on. Yeah, that's it really. Sorry. Bye.